is this: introduction, review, methodology, data analysis, validation, and conclusion. Introduction. The purpose. The risk of the sinister in the provision of logistic service without the urban environment can be characterized for Bogotá as the level of urban area at the time of the day. The logistic service use motor vehicles to the transport this cargo. The loss or impairment of the functionality of motor vehicles affect the provision of the logistic service. Design methodology apparatus. The municipal government has a public database with the register of the traffic accident information available for the period 2050 to 2090. This test describes the safety of the personal insured homicides due to the motor vehicle traffic accident. For this, it uses the public information available then an ANOVA model is an implement using an factor the year, the width of the year, the date of the week. Then the techniques of the signal analysis are used. Consider an expected power, wavelength analysis for the identification of common parents. Result. In this way, methods are available to describe the evolution of the sector of the anticipate possible change in the road accident rate, with the above the homogeneity of behavior over time is identified. Oh, I continue. Review. This review is about different articles word about this accident in different topics and different methodologies for to be analyzed with the statistical this situation. But is to say see different topics like road accidents and after location with the different dates and the consequence like injuries and homicides. This in 5 years. Well, methodology. First, the data was collected. Then we introduced to the verification and standardization of information is necessary. With what information? Road accidents. Date and the time for all road accidents and his location and the consequences like injuries and homicides for 5 years, in this case this year. So, where is the methodology? In 5 steps are identified. This is the purpose of this model. First, the data was collected, and after, then we propose the verification and in the standardization of the information is necessary. Columns are to collaborate for the categorical variables associated with the date and time components. For use an ANOVA model are available with linear regression of specific speeds for categorical variables. There are complies with the assumption and the proportion of information explaining for the total base database and for the data group in daily records for both personal injured and homicides are identified. And finally, it is concluded on the adequacy of the model used and explained proportion. The hypotheses tests are the utility and model to explain to the data and disciplinary variables. This is in all 1,826 dates. Well, this is the all insured. In this case, no, a moment, is this one. This is the road accidents. In this case, 1,073 excuse me, 443 road accidents in 5 years in Bogotá. All these dates is to date, but we in any specific with the locality. In this case, for Colombia, Bogotá had 20 different localities. So is any for any years the analysis. In this case is very vivid. Well, and the other is the consequence. For example, with the insurance. Insurance in this case is 81,714 insured. In this case, with the different years and different localities. And This is the number of deaths in the road accident in Bogotá in this period. In this case, for any years, any located. Well, this is the analysis in this case. Different place, matter, mean, standard deviation, probability, and it is an analysis with the Karachas, asymmetry, and with the significative correlation with the experiment in this case. So with this information, or analyze who is the characteristics in this any locality or in different time during 1 year, in 5 years. This is the analysis. Has the coefficient of the linear regression with a categorical variables for A responsible variables. A variables. 1, 2, 3, 4, 5, 6, 7, 8. Injury there, in this case, present locality, and the other register locality, and day locality, injury and death, and even injury and death. But in this case, it's all the p-value. P-value for everyone. The first, in this case, is D or Y. In this case, is the day of years. Day of years. The other is width of the years. It's the number of the years. The other is day of the month. Any date for the month, and the other is day of the week. It's for to know with the p-value that this model who is explain injury, in this case, injury and death. This is the p-value. Who is a good p-value? When it's near to 0. This is a good answer for the model. But when have a lot, for example, this one, don't explain in this case. So the p-value in any case is good, quite very good. Another don't is pertinent to use. This is the analysis for different time in the years and different place in the city. So this is another way to understand this analysis. In this case, you can use different place. This is the different location in the city, and this is the constant in this case, and this is the significate. We have 4 asterisks. Is a good significate. It's like a good model to explain injury for any place, to explain when use in this case injury, and there. When don't have in the significant series asterisk, no is good to use. But when the dates, for example, in this case, for the years, in this case, 20,055 is good, 20,016 is good, and
2000.
For example, 20,017 is good. But the other not good for this case don't be here. Well, in this case, for the day of the week, for example, day of the week have 7 days, but here is 1, 2, 3, 4, 5, 6. The 7 not because the model don't display good. In this case, it's good for the asterisk. In this case, for the injury, but the day don't speak good. Only no anyone. But with the month, day of the month have 30 days. In this case, you only is good with the 27 day and 29 day, for example. But don't display in this case in the jury, but good in something good in the there. Explain something. These other days is the week of the year. The year has 52 weeks, but here is 5, 6, 7, and 2, 6. Who is the significant in this case? This is the rest of the table. We can see who difference width of the years. In this case, this is displayed the different accident in this city for 5 years. But this is the same, but in a graphic. The evolution for the number of the registration, the number of wanted, the number of the deaths in present. The dotted line has the right scale, the coefficient for the number of deaths according to the width of the annus coefficient differ associated with the previous age. In this case, for example, the left here is the total accident, and the right in this case is all the death. This all the for stationary for 5 years. And the others, this line, like in naranjas, is the injuries. The injuries. Okay.
Orange.
It's the same in this case. So, the method to find it is to know with the significate, with the statistical, to know this a variable difference, who is the most explicated in this case. So, every two is good in all case to explain very good the situation. For example, in others, don't is something good because, for example, in this they don't display here, but it's good here in jury in this case with the location. But the other data is very important is the p-value. In this case, is very small. So don't have reshapes in this case. So conclusion: the statistical models are available for those injured by road accident associated with the date of the civil calendar of the minimum major office. Such models display between 36% to 63% of the information. There are no statistical models in the practical or empirical sense, although they are from the statistical point of view for the deaths due to the road accident associated with the day of the civil calendar and the minimum major office. Such model explain between 0% and 3% of the information. There is no homogeneity in the homicide event in a road accident. Other models could be used, such as acoustic or electronic scene analysis to capture frequencies and periods of common occurrence. Well, so thank you very much. This is more. Somebody had any questions?